Burger Queen allows free refills of their soft drinks. The management has found that the amount of soft drink dispensed per refill is normally distributed with a standard deviation of 15 mils. If 15% of refills are more than 230 mils, so the probability of X being greater than 230 mils equals 15%. So if that's the case, find the mean. So we need to say, what is the mean? Now we have a problem, because when we go stats, distribution, normal distribution, inverse normal, where's the tail going to be? Greater than 230. The tail's going to be to the right. The area is 0.15. Now we've got an issue because I don't have the mean. I've got the standard deviation, but I don't have the mean. So what I do is I use the standard deviation of 1 and the mean of 0, and that gives me my Z value. So what I'm going to write here is the probability that Z, so that's the normalized thing, is greater than something equals 0.15. So when I execute this, I get my Z value of 1.0364. Now I need to look at that formula converting from the Z value to the other value, and that is on page 202. In amongst all the stuff there, it goes Z equals X, you take away the mean and you divide by the standard deviation. Sweet. So now we know that our Z value is 1.0364, which equals our X value of 230, taking away our mean and dividing by our standard deviation. And now we have a lovely little bit of algebra. So if you're algebraically competent or confident, you would know to go 1.0364 and then times by 0.15. Oh, I've got the wrong number. Thank you. So 364. And then I'm going to times by the 0.15, and then I'm going to take away the 230, and that's going to give me my negative mean. So my mean is actually going to be 229.84. Now if I couldn't do that algebraically, what I could have done is gone into equations here and then gone into solver and then gone 1.0364 shift equals, I'd have to be competent enough to know that I've got to put brackets in, 230 minus my mean, close the bracket, divided by 0.15, and hit the button twice and I get the same number. So if I can't algebraically rearrange that, I can check myself with that. Now we need to put it in context. What's that 229.84 mean? It's in mils. Now think carefully about rounding by going back to the question and deciding which way to round it, because you've got to be quite careful on that. Or you could just leave it like that and put mils. Yes, I've got the wrong answer because my standard deviation is 15 mils. Okay, I got confused between my 15 mils and my 0.15 being my probability. So I need to actually change my answer. So here we go. How do we get back up to here? I needed to go across. Can I even? Yes, I can. And not have 0.15. There we go. And so now I've got the 214. 214.45. Okay? Yep. Yep.
What's your area 1, 5?
Yep, so the 0.15 there came from the 15% of refills. So the 15% was my area, yeah.
Okay, because when you put it into the calculations, it would exit an error.
Okay, so if I go stats and I go distribution, normal distribution, if I go NCD and I said that my lower was my 214.45, which is what we calculated, and the upper being 99999, and the standard deviation being 15, and the mean, oh sorry, my bad, 230. 230, 999, our standard deviation of 15, and our mean of the 214.45. So what are we expecting to come out? Our 15%. So I've tested the answer.
Okay, because if you go into inverse normal.
Okay, if I'm going menu, stats, exit, distribution, normal, inverse normal, yep.
And if you have it as 1, 5.
No, the area is 15%, it's 0.15,
Okay.
and then the standard deviation is 15. So the mistake I made here was that I put the area here instead of the standard deviation.
Okay.
So just looking back at that formula, that you should know kind of off by heart, z equals x minus the mean divided by the standard deviation. There is no area in there. Okay?